Hello and welcome to another case study of Net2Plan. Throughout this video, you will learn how the generic protection segment algorithm works. This algorithm is one of the provisioning algorithms of the resilience simulation tool included in Net2Plan. Before continuing, we recommend that you watch the videos Case Study Resilience Simulation and Case Study Resilience Simulation Algorithms. Background and some basic concepts frequently used in Net2Plan. Protection segments. A protection segment is defined as an ordered sequence of links with a certain volume of reserved bandwidth, which is used to partially or completely protect one or more traffic routes, taking an alternative path to the primary one. Shared risk groups, or SRGs. A shared risk group is a set of links and/or nodes that are assumed to share a potential cause malfunction. Thus, when a malfunction occurs, all of the elements in the SRG will fail simultaneously. For example, in this simple topology, three different SRGs are defined. If the SRG number 1 fails, both links belonging to this SRG will fail simultaneously. If the SRG number 2 is the one which fails, only this link will fail. If the SRG number 3 fails, only this link will be affected. An important feature of the mechanisms assuring network resilience is the way in which resources are reestablished in case of failure. Reestablishment techniques can be classified into three different categories. The first one, path reestablishment. When an element of a path fails, a new route between the ingress and the ingress node of each active communication traversing the affected element should be found. The second one, subpath reestablishment. A backup route between the predecessor node before the failure and a node after the failure should be found. And the third one, link reestablishment. A backup route between the adjacent nodes of the affected element should be found. I will now demonstrate how these three reestablishment mechanisms can be implemented in Net2Plan using protection segments. To do so, we will use the offline network design tool of Net2Plan, and we will load a simple topology to illustrate the three different reestablishment techniques. So you can see this topology has only one demand between the node 0 and 3, and one route carrying that demand. An offered traffic of 5 erlangs, and all the traffic is carried through that route. There is no protection segment defined on this topology, and a shared risk group SRG is present with two links, 2 and 3, belonging to that SRG. That means if the SRG fails, both of these links will fail, and then the route will be affected and all traffic will be carried. So, to add a protection segment, just go to the Protection Segments tab, right click, Add Protection Segments. In this window, you can select the origin node, in this case the node 0, and add a sequence of links conforming the protection segment. For example, we will go over this path here, so we will select the links between the node 0 and 4. As you can see, it's drawn in blue. You can add a new link to this path between the node 4 and 5, 5 and 6, and so on to the destination node number 3. As you can see, once you have defined the path of links, you can set the reserved bandwidth for these protection segments. We will set it to 5, the same amount of the offered traffic. Okay, as you can see, the protection segment has been created, and it says here that it's not used, because although it has been created, it has not been assigned to any routes yet. To do so, go to the Routes tab, select the route, right click, view edit backup segment list. You can see the list of protection segments defined. Select, there's only one for now. You click on add, and now it's assigned to that route. You can click the view button. In blue, the original route, and as a dashed line, the protection segment. As you can see, this protection segment implements a path reestablishment technique. I will proceed now to illustrate the subpath reestablishment mechanism. Again, the same topology is loaded, and we'll create another new protection segment. This one will be from the node 0 to the node 4, 4 to 5, and 6 to 2. As you can see, this is the subpath reestablishment technique, because if those two links fail belonging to the same SRG, then a new path of links will be defined from the node 0 to the node 2, because the original route that goes to the node 2 to 3, this link will remain available. Now that the protection segment has been defined, it must be assigned to this route. Again, you can see the original path of links and the new protection segment covering and backing up this route. That is the subpath reestablishment technique. And now, the last of the reestablishment mechanisms, the link reestablishment. We will create a protection segment between the nodes 1 and 2 through this path here. To do so, once more, go to protection segments, add protection segment, and we will select from the node 1 to node 4, 4 to 5, 5 to 6, and 6 to 2, as you can see here. Again, the reserve bandwidth will be 5 erlangs, and we will assign this protection segment to the root. And as you can see, that in case of failure of any of these two links, this path of links, this protection segment, will act as a backup route. If you want more information on how to use the offline network design tool, please watch the video case study offline network design. When defining resilience policies for your network design, some options used by the generic protection segment algorithm may be considered. For example, dedicated versus shared protection. That means protection segment is assigned only to one route, or if it is shared among 2 or more routes. I will illustrate this in Net2Plan using the same topology as before, with a protection segment as a link reestablishment. We will change the offer traffic, for example, to 10 erlangs. As you can see, since only 5 erlangs are covered, the traffic loss is to 50%. And we will define another route using the same path of links as the original route. Now we will have 2 routes traversing this path of links. And covering 5 erlangs. As you can see, now 2 routes carrying this traffic. If you look at protection segments, you can see the dedicated column that it says that this protection segment is dedicated. That is because it has been assigned to only one root. If you go to this root and assign the same protection segment to that root, you can see now that this protection segment is now shared, because two roots have this protection segment as a backup root. The next option is the partial protection. That means if all the primary traffic is protected or not. That can be set by the root attribute partial recovery allowed in Net2Plan. Imagine now that the protection segment that we have defined has a reserved bandwidth of 7. If those links fail, then both routes will fail simultaneously. But since the carried traffic by each route is 5, giving a total of 10 airlines, then this protection segment can't protect all this traffic. If the partial recovery option is activated, then the protection segment can partially recover the traffic of one route. For example, it can recover the whole traffic of the route 0, that is 5 airlines, and recover 2 traffic of the route number 1, that is 2 airlines. And under the routes tab, we will go to add edit attribute to all. The name of the value, partial recovery allowed, and the value true. As you can see now, the attribute has been added to both routes with a value of true. If the partial recovery is not allowed, when a route fails, even though a protection segment exists, if it can't carry all the traffic, if the partial recovery allowed attribute is set to false, it will not use that protection segment. Revertive or non-revertive mode. Until now, if a route fails, the generic protection segment algorithm will try to route the traffic using a protection segment assigned to that route. But what happens when the nodes and links are repaired? If the attribute revertive mode is set to true, the algorithm will try to restore the traffic to its original primary path. As we have seen, if one of these two links fail, then the traffic of the two routes will be rerouted by this protection segment. But if we want the traffic to return to its original state, that is being carried through this path of links once these links have been repaired, we can go to routes, again add edit attributes to all, and set an attribute called revertive mode and set it to true. As you can see here, the generic protection algorithm will try to reroute the traffic to its original path once the affected links have been repaired. The next option, provisioning priority. The generic protection segment algorithm will check the affected routes, rerouting the traffic if necessary, in descending priority order. All the routes have a default priority of 0, but that value can be modified by the attribute route priority. For example, using the same topology, we can see here that we have two routes. Since they all have the same priority, that is priority 0, the generic protection algorithm will check them following the ascending order of their identification number. That is, since we have a reserved bandwidth for this protection segment of 7 airlines, if one of these two links fail, the generic protection algorithm will assign 5 airlines to this route and the remaining 2 airlines to that route. if by some reason we want this route to be rerouted first and then be assigned 5 airlines to cover all the carrier traffic of this route, we can just add an attribute, route priority, and set it, for example, to 1. As you can see, now the route number 1 has more priority than the route number 0 and will be rerouted by the generic algorithm, the genetic protection algorithm first. Some other options can be explored while designing resilience policies using Net2Plan. For example, preemption, to reduce the traffic of low priority routes to reallocate high priority connections, or loop prevention, that is to avoid the use of link loops when rerouting traffic. As said before, the generic protection segment algorithm is one of the provisioning algorithms included in the resilience simulation tool of Net2Plan. If you want more information about how to use the resilience simulation tool, please watch the video Case Study Resilience Simulation. This algorithm is based on the protection segment concept. It works with almost any of the previous approaches, depending on the definition of protection segments on SRGs in the network design. The purpose of the algorithm can be abbreviated in 2 basic ideas. The first one is to apply pre-reserved bandwidth to protect routes affected by different failures. The second idea is to restore those routes using backup paths to the original routes when resources become available again. Also, since Net2Plan and all the included algorithms are open source, you can download the source code at any time and code new features to extend its functionality. I will explain how the generic protection segment algorithm works internally in a case of failure scenario. Given a failure event and the network state before that failure, the effects of the failure are obtained, that is, the current active nodes and links, the affected routes, the available capacity, and so on. The network state after the failure. Then, the algorithm will sort all of the affected routes by descending priority order. Again, the priority of the routes can be controlled by the attribute route priority. Once all the routes have been sorted, the algorithm will analyze each one of them. It's important to note that only routes whose end nodes are available are considered. That is, because if an end node is not available, no traffic can be received. Then, for each one of the affected routes, the algorithm will check all of the protection segments that are not affected assigned to that routes. Then it will take some actions. I will explain this on the next slide, and those actions will be returned to the kernel of Net2Plan to be processed. For each one of the routes of the network, all of the protection segments assigned to that route will be analyzed one by one. First, it will check if that protection segment can recover the whole route. That means that if the failure event has affected any links or nodes of that protection segment, then it cannot be used as a backup route. So it will proceed to analyze the next segment. If it can use the route, it will try to recover all the traffic. If indeed it can, it will create a rerouting action and proceed to analyze the protection segments of the next route. If it can recover all the traffic, it will check if the partial recovery is allowed. As we have seen before, the partial recovery mode can be set with the route attribute partial recovery allowed, that is a boolean. If the partial recovery mode is activated, it then will create a rerouting action and proceed to the next route. If the partial recovery mode is not allowed, then this protection segment cannot be used by the algorithm and will proceed to the next segment. Now, the behavior of the generic protection segment algorithm in a reparation scenario. Given a reparation event and the network state before the reparation, the effects of the reparation are obtained. Next, the algorithm will sort all of the affected routes by descending priority order. Again, the priority of each route can be controlled by the attribute route priority. Once the routes have been sorted, each candidate to repair route will be analyzed by the algorithm and some actions will be taken. I will explain this on the next slide. Those actions will then be returned to the kernel of Net2Plan to be processed. For each candidate to repair route, that is a route that failed before and was being backed up by a protection segment but now has all its links and nodes available, the algorithm will first check if the route is in revertive mode. Again, remind you that the revertive mode of a route is controlled by the route attribute revertive mode. If the route is not in revertive mode, it will continue to carry the traffic through the protection segment and then will proceed to the next candidate to repair route. But if the route is in revertive mode, then it will check if the original path has enough capacity to carry all the traffic. If not, it will proceed to the next candidate to repair route. But if it can carry all the traffic, then it will create a restoration action. Then it will proceed to analyze the next route. I will proceed now to review the source code of the generic protection segment algorithm. If you want more information about the provisioning algorithms and the failure reparation event algorithms of the resilience simulation tool, please watch the video Case Study Resilience Simulation Algorithms. This video explains how these algorithms are coded and how to modify them and create new ones. But for now, we'll focus on the process event method of the generic protection segment algorithm. First of all, you can see that a new list of provisioning actions is being created. All of the actions that are going to be performed to the topology are then added to this list, and this list is returned to the kernel of Net2Plan to be processed. Next, we will check if the new event to be processed is a failure event or a reparation event. In case a node or a link has failed, it will proceed to the failure scenario that we have reviewed before on the flow diagram. It will then get the failure effects from the net state, getting a list with the affected routes of the network, removing those routes that can be unrecoverable. It will proceed then to sort these routes by descending priority, and then check each one of the protection segments of each one of the routes. So for each route, it will check all of the protection segments of that route, checking if that protection segment has all its links available, if it can recover all the traffic of that route, or if the partial recovery allowed mode is activated. If any of these requirements is not met, it then will proceed to the next segment. If not, you can see that a new action is added to the list containing the modification of the route carrying the traffic by that particular protection segment. Then, once all of the protection segments of all the routes have been analyzed and the action have been taken, it will proceed to return this list of actions. But if instead of a failure event, a reparation event has occurred, it will again get the reparation effects of the net state, creating a list with the candidate to repair routes. Again, those routes will be sorted by descending priority, and each one of these routes will be analyzed. First, and most important, if the route is not in revertive mode, then it will proceed to the next route. If indeed it is, it will check if it can recover all the traffic of the route and if all the links of the new route are available. Then the route will be set to its original primary path, and a new action will be added to the actions list. As you can see, a modification of the route with the original sequence of links. Once all the routes have been checked and modified, then the actions list will be returned to the kernel of Net2Plan to be processed. And that's all. Thanks for watching, and please visit net2plan.com.